Welcome to another episode of AI Talks with Chris and Nita.
Hey, everyone.
Today, we're diving into how computers sort of figure out what words mean. We're talking word embeddings.
Yeah, it's basically like giving each word its own, numerical fingerprint.
It's unique fingerprint. And we're not just looking at any method today, right?
No, we're digging into a specific, more advanced one. It looks beyond just the single word.
We're using a document called Embeddings from Language Models as our guide for this deep dive.
Yeah.
And our mission really is to understand how this particular technique, that's called ELMO, how it differs from the earlier ways of doing this, and why that actually matters for AI understanding language.
Okay, so let's back up just a tiny bit. Word embeddings, the main goal is to capture a word's meaning numerically in a vector.
Right, a vector like coordinates on a map.
Exactly. So words with similar meanings, they end up closer together in this abstract vector space.
Okay.
And methods like word2vec, CBOW, skipgram, glove, they were huge steps. They gave us ways to actually measure word similarity.
So those were foundational. They let computers start processing language in a more meaningful way. But they had a limitation, didn't they? They gave each word just one fixed fingerprint.
That's the core issue, yeah. One vector per word, no matter the context.
Okay.
Then comes ELMO. That stands for Embeddings from Language Models, developed by Allen NLP. And it completely changed the approach.
How so? What was the big shift?
It said, fundamentally, that a word's meaning depends on how it's used in a sentence. Context is king.
Okay, this is where it gets really cool. So instead of one fixed fingerprint,
ELMO generates the embedding, that numerical fingerprint, by looking at the entire sentence the word is sitting in.
the whole sentence. How does it manage that?
It uses something called a two-layer bidirectional language model, a BILMLM.
Bidirectional. So it reads forwards and backwards.
Kind of. Think of it like reading the sentence left to right to get the forward context, and then also right to left for the backward context.
Ah.
And it does this processing on two different layers internally.
Two layers. Okay,
Yeah.
so layer one looks forward and back. Layer two looks forward and back. Analyzing the word based on what comes before and after.
Precisely. And the really powerful thing is, the same word can get different vectors, different fingerprints, depending on the sentence.
Ah, that allows it to capture nuance, right?
Exactly. That's the key. It gets those subtle shifts in meaning.
Like your example of the word bank. If I say, I need to go to the bank, that's one meaning.
Yep. Financial institution.
But if I say, we sat on the riverbank, that's totally different.
Completely different. And ELMO can generate distinct embeddings for bank in those two sentences because the context tells it what's going on.
That makes so much sense. It allows the AI to understand language in a much richer, more human-like way.
Definitely more nuanced, yeah. Those earlier methods like glove and word2vec, they were critical. They laid the groundwork, but ELMO's context awareness was a major leap.
So wrapping up the main point, Elmo's big innovation was looking at the whole sentence to figure out a word's meaning, moving beyond those older, static, one-size-fits-all embeddings.
That's the core takeaway, a huge step forward.
And when you think about it, that ability for AI to grasp context, it changes things, doesn't it?
Oh, absolutely. Think about how much better AI can potentially get at understanding what you mean, whether it's in search or chatbots or analyzing complex text.
Definitely something to ponder. How might that deeper contextual understanding reshape the AI tools we interact with every day?
Great question to leave folks with.
Thanks for this deep dive.